Let's look at factoring special products. We're going to start with some noticing. What do you notice? We will look at some patterns in order to figure out two new special factoring cases. So let's get ready. You're going to need your notebook, pencil, and a calculator. There are a lot of problems in this one because we're trying to be mathematicians and notice patterns. Good luck. What do you notice here? Hopefully you notice that these are each perfect squares. 5 squared, 6 squared, 7 squared, 9 squared. What do you notice here? 1 is a perfect square. 1 squared, 2 squared, 3 squared, 4 squared. You really need to get familiar with these. You can figure them out by squaring everything, but you should be familiar with the numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So you can recognize that they're perfect squares and use them. What is the answer to a subtraction problem? We call it the difference. So now we're going to put those two things together, perfect squares and differences, and we have our first type. It's called the difference of two squares. So this means that we're going to be subtracting, and this means we're going to have something squared. So let's take a look at what some of these are going to look like. In our first example, we have a difference because it's subtraction. X squared is the perfect square of x. 49 is the perfect square of 7. So we're going to keep that in mind. I do want to relate back to what we've been doing with our trinomials. So I'm going to write this as a trinomial. This would be x squared plus 0x, because I don't have that middle term, minus 49, so that a is 1, b is 0, and c is negative 49. If I do my x puzzle and what multiplies to a times c, I have what multiplies to negative 49 and adds to b will be a 0. That's interesting. Well, 49, we could get that from 7 and 7. If we make one of them negative, that will add to 0. So because a is 1, I can go right to my parentheses, and I have x plus 7, x minus 7, and it's factored. Okay, let's try another. Here I've written it with that 0 term in the middle, so we can go to our x puzzle. What multiplies to negative 1 and adds to 0? 1 and negative 1. So I can go to those for parentheses. Let's another. Again, this is a perfect square. This is supposed to be a minus there, sorry. Minus 25. So we're going to do, oh no, what's going to happen here? Well, you know what, let's keep it a plus for a minute. So if we do it as a positive 25 and what adds to 0, well, 5 and 5, but that's going to go to 10, and it can't be negative because we've got a positive. So this one does not work. And I did intend for that because it's not a sum. It's not x squared plus 25. It's called a difference. It's not, there is no sum of two squares. If you get that, it is not factorable. And we call that prime, like a prime number. All right, let's try this one. I'm going to do what multiplies to negative 64 and adds to 0. Well, that would be 8 and negative 8. So we have x plus 8, x minus 8. Are you starting to see a pattern? This first number, if we take the square root of that, that's x. Second number, if I take the square root of that, that's 8. And then one always seems to be positive and one seems to be negative because I have to get to that 0. So let's see if we can skip the x puzzle and go right to the parentheses and if it works. So we have a perfect square. We have subtract a perfect square with our 0 here. So if I think about the square root of x squared, it's x, and the square root of this, it's 10. So we can try x plus 10 and x minus 10. I'm going to multiply it and check it out. So x times x is x squared. X times negative 10 is negative 10x. 10 times x is a positive 10x. And 10 times negative 10 is negative 100. Notice these middle terms will go to 0, and I end up with x squared minus 100. So it works. This is fully factored. Let's look at this one. If you notice, a is not 1 anymore, but it is still a perfect square. So the perfect square is 2x, and the square of 9 is 3. So this will factor to 2x plus 3 and 2x minus 3. We could multiply that out and check it, but that is in full correct factored form. So you take the square root of the first, the square root of the last, one is a plus and one is a minus, and that will be the pattern called difference of two squares. If we look at it in letters, here we have a squared minus b squared. One of them is a minus b and one of them is a plus b, and that will always work. Let's switch over to our second kind, and this is called a perfect square trinomial. Notice we have a tri, so we have 3 terms. And we're going to rely on our X puzzle. So we're going to do what multiplies to 9 and adds to 6. That would be 3 and 3. A is 1, so I can go right to my parentheses, x plus 3 and x plus 3. Because they're the same, we can actually call this x plus 3 whole thing squared. Either would be factored, but this is kind of considered the more correct way of writing it. Let's take a look here. It is a trinomial. The first is a perfect square. The last is a perfect square. So we're looking at the square root of the first is x. The square root of the last is 5. And we want to think about how we get that 10. So, well, if I were to multiply it by 2, that would give me 10. We're going to see if that works in the next one. So let's factor it. So what multiplies to 25 and adds to 10, that would be 5 and 5. So we have x plus 5 and x plus 5. And I can put that together for x plus 5 whole thing squared. So we noticed that this is a perfect square of x, this is a perfect square of 6, and it does happen that if I multiply this by 2 again, I get the 12. So that's the pattern. This middle b value has to be 2 times the square root of the first and the last term in order for it to be considered a perfect square trinomial. So I'm going to do my x puzzle, and I'm going to think of what multiplies to 36 and adds to 12, and it's 6 and 6. So I get x plus 6 and x plus 6. They are the same, so I can call that x plus 6 whole thing squared. Are you starting to see a pattern? Do we really need this x box? Let's see. All right, so if my first term is x squared and the square root of that is x, and my last term is 49, square root of that is 7, any guesses as to how I get my middle term? Well, we noticed that it was being multiplied by 2, so I think it's going to be 14x. And now that completes our perfect square trinomial. So we can factor it. And I'm going to try not to do the x box. I'm just going to look at my square root. So I'm going to take the first square, which is x, the last square, which is 7. And this is kind of a little trick there, the sign of b. So that is going to be a plus, whole thing squared. If you can recognize this pattern, if you can see that it's a perfect square trinomial, it's going to save you a lot of time. Let's look here. First one is a perfect square of x. Last one is a perfect square of 9. Together, multiplied by 2, I do get the 18, so it is a perfect square trinomial. So I can go to x plus 9, whole thing squared. Back here, we had plus. Oh, what's different? Up here, we have minus. So we're going to take the square root of the first, the square root of the last, and the sign of b. So this one becomes x minus 9, x minus 9. Let's just double check. X times x is x squared. X times 9 is negative 9x. Negative 9 times x is negative 9x. And negative 9 times negative 9 is a positive 81. So it does in fact go to x squared minus 18x plus 81. So we can say our answer is x minus 9 whole thing squared. That is the factored form. Let's check this one out. The square root of the first term is x. Notice my sign of b, and the square root of the last is 10. So this is going to go to x minus 10 whole thing squared. Pause and give this one a try. All right, we do notice that a is not 1 anymore, but it's still a perfect square. The square root of that is 2x. The square root of this is 3. 2 times 3 times another 2 is doubled, so it's 12. So this one factors to 2x plus 3, whole thing squared. Let's try that again. So 16 is a perfect square of 4, so my first term square rooted is 4x. My last term square rooted is 5. Double that for my middle, and I get 40. My sign of b is positive, so it's 4x plus 5, whole thing squared. And our last one, perfect square, my sign. This is 3x when it's square root, and this is 4. So this becomes 3x minus 4, whole thing squared. That's why it's important to be able to recognize your perfect squares so you can save time with factoring. So the pattern with a's and b's become this. Notice that the b squared is always going to be positive. Because you're squaring, it's going to be positive. If we have a positive b, then we have a positive b there. If we have a negative, then we have a subtraction sign there. As I was making these in Desmos, I typed in all of these beautiful equations, and look at these amazing graphs they gave us. We haven't started graphing parabolas yet, but we have those, and you can see these two negative ones. These would be this because this is at 9 and this is at 10. I just thought I would share it with you as we were noticing some patterns. So this should get into your notes if you didn't write them down during the video. The difference of two square pattern starts out kind of short. It's a binomial, and it goes to two different parentheses, whereas a perfect square trinomial is a trinomial that ends up as a binomial. So just some things to notice there. Here's all the factoring types that we've done so far. We started off with factoring by grouping, which was 4 terms, and we used the GCF. Then we factored trinomials when a was 1, and we had to use the X puzzle, and we went right to parentheses. If a was not 1, it was a little more work. We went through X puzzle to grouping to the answer. And here are 2 new ones and our final ones, difference of 2 squares and perfect square trinomials. Good job. You have become a master factorer, and here is a trophy to celebrate.